All right, these are our notes, additional notes to add to your notebook on section 10.1. And section 10.1 is talking about your basic conditional statements and then some manipulation of that conditional statement. So a conditional statement is just an if statement. It's used to compare two things. We're going to be talking about more if statements in section 10.2 and how to apply those to Excel spreadsheets. So when you consider the statements, P is a symbolic representation of it rains, and Q is a symbolic representation of I take my umbrella. P is called the hypothesis, and Q is called the conclusion. So for a direct conditional statement, which I would write symbolically as P implies Q, and I just say P implies Q, and you can also say if P then Q. I can rewrite that by substituting in the P and Q value. So if it rains, then I take my umbrella. So negation is when you take the opposite of one of the actions. The little tilde symbol in front of the P or the Q implies that you are negating it. So the negation of P would be it does not rain. If I have a statement such as I do not like sardines, then the negation of that statement would be I do like sardines. So when you're writing the negation, don't do the double negatives. Don't say I do not like sardines. And don't pick something else. Like instead of saying I do not like sardines, say I like pepperoni. So make sure that you still use the same words in the sentence. Okay, the converse, notice that the Q and the P are being switched. So that means the if is staying in the same place and the Q and the P are changing. So if I take my umbrella, then it rains. Okay. The inverse is when I negate both of the P and the Q, but I don't change their order. So if it doesn't rain, then I don't take my umbrella. And the contrapositive is when I switch them and I negate them. So if I don't take my umbrella, then it doesn't rain. So one of the statements they want to make is that the converse is not logically equivalent to the conditional statement. So in this case up here, if you want to think about it, just because I carry my umbrella doesn't mean it is raining. So for example, I use the example, I have an umbrella in my car all the time, but that doesn't mean it's raining outside. Okay, the contrapositive is logically equivalent to the conditional. So more than likely, if I don't take an umbrella, then it's not raining. So that would make sense. So one of the other things that we have in this section is what we call truth tables for conditional statements. So a truth table is when you're trying to decide whether a statement's going to be, the final statement's going to be true or false. So if the P and the Q are true, then the final statement is true. So if it rains is true. If I take my umbrella is true. Let's assume that it's raining and I take my umbrella. Then that means it must be a true statement overall, right? But what if it is raining and then I don't take my umbrella? Well, I'm going to get pretty wet, right? So that would be a false statement. That's not a good statement. What if it doesn't rain, but I still take my umbrella, right? Nobody got hurt. I just carried my umbrella with me for no reason, but, I had it just in case. And the last one is if it doesn't rain and I don't take my umbrella, then everything's good, right? So I also like to use this example here. And this is, if you can imagine, if you have children, you can deal with this. If you eat your green beans, then you're going to get some dessert. So this is the promise that you made to your child. So he ate his green beans and he got his dessert. So everything happened the way it was supposed to. He's happy because he got to have his dessert. So what if he ate his green beans, but he didn't get dessert like he was supposed to? So that's a false outcome. He's not happy because he did what he was supposed to do and he didn't get his reward. So what if he didn't eat his green beans and he didn't get a dessert? Okay, well, I'm sorry, and he did get dessert. Well, even though it didn't follow the right way, he's still happy because he got his dessert no matter what. So that's going to be a true statement also. And the last one is he didn't eat his green beans and he didn't get dessert. Well, he knew the consequences of what was going to happen if he didn't eat his green beans. So it's a true statement. Okay, so then when we apply that to some of the examples that you'll see, so if tigers can run, then tigers have flippers. Well, the hypothesis is tigers can run. That's the P part. Is that true? And the answer is yes, tigers can run. So the conclusion is the part that says tigers have flippers. Is that true? Do tigers have flippers? The answer is false. So what I have here is true implies false. So according to my truth table, that's a false statement overall. Okay, our next one. Tigers can run, then tigers are dangerous. The hypothesis is tigers can run. The conclusion is tigers are dangerous. Both of those are true statements, assuming you're in the wild. And so true implies true. True implies true is a true statement. So these are some of the different formats that you could see for different things. And all of these mean the same thing. So if P, then Q. If P, comma Q. Sometimes we don't put the word then. So like I might say, if tigers can run, then they're dangerous. And I don't necessarily have, or I might say, if tigers can run, tigers are dangerous. So it's implied that there's a then there. P implies Q. So I could say tigers can run implies that tigers are dangerous. P only if Q, tigers can run only if they're dangerous. Okay. P is sufficient for Q, tigers can run is sufficient for tigers are dangerous. Q is necessary for P, tigers are dangerous is necessary for tigers to run. Don't know if that's necessarily a true statement, but P are Q, all P are Q, all tigers can run, and all tigers are dangerous. And then Q if P, tigers are dangerous if tigers can run. So watch out for that if. So then we have another example here with Algebra 2. It says, if you take Algebra 2, then you pass Algebra 1. So that would be P, it would be if P, then Q. If you take Algebra 1, you pass, if you take Algebra 2, you passed Algebra 1. So that would be if P, comma, Q. Taking Algebra 2 implies that you have passed Algebra 1. That would be the P implies Q. You can take Algebra 2 only if you passed Algebra 1. P only if Q. Taking Algebra 2 is sufficient for having passed Algebra 1. P is sufficient for Q. Passing Algebra 1 is necessary for taking Algebra 2. Q is necessary for P. All Algebra 2 students have passed Algebra 1. All P are Q. And then the last one, you have passed Algebra 1 if you were taking Algebra 2, Q if P. So again, these are all just different ways to say the same thing, and you can come up with the hypothesis and conclusion. I hope it helps.